Hello everyone. Today I will be giving an introductory presentation on quantum natural language processing. Before we jump into the topic, let's go over what's quantum computing. In simple words, we can say that it's a computing using quantum mechanical phenomenon which is based on entirely different physical processes than what we currently use, such as superposition and entanglement. Potential power of this quantum computers was first mentioned by physicist Richard Feynman in 1982. It has a typical use cases like quantum simulations, quantum linear algebra for AI and machine learning, quantum optimization and search, and quantum factorization. One important thing which I would like to mention at the start of presentation is that the use cases of quantum computers are very largely experimental and hypothetical. As of today's quantum computers are very small and noisy, where current computers can easily outperform those. But it is not too early to think about possible use cases, possible impact of quantum, and quantum safe encryptions of data and communication. The properties of quantum states which we have, those are superposition, interference, and entanglement. In superposition, we can say that we are aware about the normal bits, which is 0 and 1, but a qubit which assumes values that are combination of both 0 and 1. That means single qubit has multiple variations of 0 and 1, that can be 0.001, 0.99. All these values are can be incorporated in single qubit. The second feature is interference. Interference, it is related to the wave function of the particle, which can either reinforces or diminishes each other. Third and most important feature of quantum computing for the natural language processing is entanglement. Entanglement is used as a sort of computational multiplier for the qubits. As we entangle more and more qubits together, the ability of the system to make calculation grows not in linear way but in exponential manner. So consider you entangle multiple qubits and they are so tightly entangled with each other that even if you send one particle to the space, which was scientifically proven that one particle was sent to the space and another was on the earth, and the changes made on the particle which was on the earth reflected on that another particle. So this is a very important features which we are going to use in the natural language processing. Now that we have understood what quantum computing is, let's talk about quantum natural language processing. That is, defining language mathematically so that quantum mechanics can be done in these language vectors using quantum computers. Now, what is mean by defining language mathematically? So there are two school of thoughts in natural language processing. First is distributional semantics, which says that words that are used and occur in the same context tend to show the similar meaning. Whereas there is another school of thought, that is compositional semantics, which asks the questions that can we mathematically prove that given sentence has a meaning which makes sense. So where does the quantum natural language processing comes in? Qnlp is this big breakthrough which is combines these two school of thoughts. So the question is, can we create a mathematical model which exposes how the information flows between the words in a sentence? The answer is Qnlp, the mathematical framework for a unification of the distributional theory of meaning in terms of vector space models and compositional theory for grammatic types. So this is the first time these two thoughts have brought together, where we can say that we are not only going to think that the words are just defined by the words surrounded by it, but we are also going to bring the meaning and the logic to it and prove it mathematically. So, how does QNLP even work? We know that meaning of words are combined to build the meaning of sentences, but how to produce the meaning of whole from its constituent words? I initially explained the difference between classic bits and qubits. Now consider example of the word bank. Word bank has two meanings. It can be a river bank or it can be a bank where all the financial activities happen. In classic bits, we will need different combination for these two different meaning. But in quantum computing, we have qubit which can hold all these meanings in a single qubit. And these single qubit can be entangled with each other to produce the meaning of whole. Let's say we have a bag of words, that is Alice hates Bob. These are three different words which are sitting in their own meaning space. That means Alice has its different meanings in single qubits, hates has its different meaning in another qubit, and same goes for Bob. This is what we call as a bag of words. So, how does we as a human make these words interact with each other to form a natural language? The answer is grammar. And this grammatical structure like binds these words together in order to form a meaning in the sentence, that is Alice hates Bob, which can be achieved in QNLP through entanglement. To make these two words entangle with each other, we need to pass them through the quantum circuit that encodes the information flow of the word meaning in a grammatical sentence. We know the AND gate, there are similar gates like quantum gates, that is C naught gate. So after going through these gates, in terms of our example, all the meanings of these words have now interacted with each other and have become tightly entangled to give us a new meaning which says that Alice is a person who hates Bob, which is another person. So, for every single possibility, like adjectives, verbs, they have now different circuits which is going to give us exactly what we are asking, the grammatical structure of between those verbs and adjectives. And it's not for only single words, it is for all the nouns and all the verbs. They have created different kind of circuits. Using these QNLP circuits for natural language processing has many advantages over current state of the art neural network models, because neural network represents sentence as a mere sequence of words. But the question is there a much more deeper level hierarchical meaning structure hidden in the sentence which neural network is failing to understand? Also, we are not sure that neural networks understands or remembers the certain patterns or artifacts which we have in the data. QNLP models are better in domain adaptation, speed, and also in interpretability. And most importantly, QNLP models can combine grammar and meaning like humans do. And these are some of the references which I used for the presentation. Thank you so much.